Number 1, classify each sequence as arithmetic or geometric. So we know that arithmetic sequences are based on adding, while geometric sequences are based on repeated multiplication. And write a recursively defined rule. This lesson was all about recursive sequences, and recursive sequences is a description of the pattern. It's not, if I want to know the 100th term, you plug in 100. That's not recursive, that's explicit. Recursive describes the pattern in symbols. Make sure you include both parts because there's 2 parts to the recursive rule. So this first sequence, 14, 21, 28, 35. So this has a pattern of +7, so clearly this is an arithmetic sequence with a common difference of 7. So when I write a recursive rule, there's 2 parts. The first term is 14, and to get to the next term, I go to the one before it and add 7. To get to the next term, where I am now is a sub n plus 7. These 2 parts together make up the recursive rule. 4, 40, 400, 4000. This is a geometric sequence with a common ratio of 10. We keep multiplying by 10 here. So it is geometric. Geometric. And the first part is the easy part. Start at 4. And to get to the next term, you do what to the previous term? You multiply it by 10. You could have also written 10 times a sub n. Doesn't matter which way you write it. You just need to say, multiply that guy by 10. These 2 guys together make up the recursive rule. Now in these 2 examples, I use the n plus 1 and the n notation. In these next 2 examples, I'm going to use the n and the n minus 1 notation. Doesn't matter which one you used, you just need to pick a notation and stick with it. So, what's the pattern here? The pattern is add 10. This is a common difference of 10. So this is arithmetic. Start at negative 101. And to get to the nth term, you go to the one before it and add on 10. You could have written the exact same sequence using the a sub n plus 1 and the a sub n notation. It's just a different way to go about writing the recursive rule. And this last sequence here, it's decreasing, it's alternating, so which is a good sign that it's geometric. That alternating can only happen if it's geometric. And if I don't know what the common ratio is, I'm going to start dividing second over first, third over second, and all of these fractions are equivalent to negative 1/3. That's our common ratio. So our first term is 54, and the nth term is you go to the one before it and multiply it by negative 1/3. Or maybe you wrote a sub n equals negative 1/3 a sub n minus 1. I don't care which notation you use. You need to pick one, the n plus 1 notation or the n minus 1 notation. But you need to recognize these are recursive because there's 2 parts to the rule, and there's a sub n's on both sides. Doesn't matter if it's n plus 1 or n minus 1. You have to pick a notation and stick with it. Number 2, consider the recursive definition where the first term is 3. I don't need dotted pink line. The first term is 3. And what is this trying to get me to recognize? This is describing the pattern, which is multiply by 4. So my common ratio is 4. This is a geometric sequence. Describe the pattern. Start at 3. We have a first term of 3 and multiply by 4 to get to the next term. To get to the next term. Write an explicit formula for this sequence. Well, the explicit formulas, those are on our reference sheets. Well, this is pretty easy because we know the first term is 3 times our common ratio is 4 to the n minus 1. That's the explicit formula for this sequence. If you want the 100th term, you just plug in 100. That doesn't work with the recursive. Recursive, you have to build your way up. All I know is the pattern is multiply by 4. So that's all I can do from the recursive. The explicit, if I want the 2017 term, I just have to plug in 2017. number 3, write a recursive rule for the sequence shown at the right. Remember, when we graph sequences, it's just a set of points because it's a discrete function whose domain is just 1, 2, 3, 4, 5. Maybe you don't like working with the picture, so the first term is 2. The next term is 5. The next term is 8. The next term better be 11. This is an arithmetic sequence because this is a linear function. Linear functions go with arithmetic sequences. Take a minute and think about what type of function goes with a geometric sequence. Hopefully you know what that answer is. But they want a recursive rule for this sequence that I listed out instead of putting it in graphical form. So, got to tell me where to start. Start at 2. And to get to the next term, what do? The pattern is add 3. I have a common difference of 3. That's my recursive rule right there. So recursive rules are all about describing the pattern and building up to get to the next term. There's 2 parts to the formula, the first term, and then the pattern. It's very easy to recognize because there's 2 parts, and there's a sub n's on both sides.